Hi everyone, I am Shubham Garg and welcome back to the lecture series of Tana. So in today's lecture we are going to use the previously created 2:1 mux to create a 4:1 mux. Okay, so before starting let me show you the circuit diagram. Okay, not this one. Yeah. So this is the circuit diagram for to create a 4:1 mux using 2:1 mux. So we are going to use 3 2:1 mux to create a 4:1 mux. All right. So you can see there I0 to I3. All these four these are inputs. The select lines are connected like this. That is, two select lines are connected together. This will be S1 and another. There is the select line for this mux. All right. So this is how we are going to create the design, and we are going to implement it using our 2:1 mux symbol which we created in the previous video. Alright, so without wasting any time, let us move towards creating a 4:1 mux. First of all, I am going to create a cell, new view, and here I am going to name it as mux_41, and this should be the type schematic. So I am going to click OK. And now in this 4:1 mux, I am going to create the instance of our 2:1 mux. So here is the first instance. This is the first 2:1 mux. This is the second 2:1 mux, and this is finally the third 2:1 mux. Okay, as in the diagram, we needed 3 2:1 mux. So these are our 3 2:1 mux. Okay, and we can see that this is the A input, this is the B input, and this is the select line. So let us make the connections. First of all, we need to make sure that these two select lines are connected together. Alright, so here we are going to take this wire and we will connect both of these select lines together. Alright, so there are the select lines. Now let's paste the inputs. That is, this is A. Okay, we can basically name it ABCD, or we can name it I0, I1. So let's name it I0 because it will be easier to name it in 16:1 mux, because we need to name from I0 to 16 later on. So I will just name it as I0, and this is the input port, that is I1. This is the third input port, and this is I2, and finally the fourth input port, that is I3. Alright, so we have named these. Now let's add ground and VDD. Okay, before that the output of this should be going towards the input. So here is this for the input. Now similarly the output of this is the input for this mux, and finally what we have is our select line. Alright, so for the select line there are the inputs. That is, first of all, this input, we'll name it as S1, and this input, that is S0. Alright, that is the select lines S0 and S1. Okay, now what we need to add is we need to add the output port here first of all. So here is our output port, we'll name it as Y, and finally the ground and VDD. Alright, so here just search for ground in the miscellaneous. Now here we have the ground. Let's take the instance. Yeah, so here is a ground, here is a ground, and here is a ground. Now again what we need is VDD. Let's take an instance. So here is a VDD, here is a VDD, and here is a VDD. So there are these three VDDs. Now what we need to do is we need to add the VDC. Okay, so here in the sources we will be adding VDC, and there we are going to create an instance. Just going to copy and paste this. So this is our VDC. Alright, so now we have our VDC and voltage and ground. Let's just save it. Now we need to add the V bit. this is our V bit here. So you can see the more inputs we are having, the more complicated the design is becoming. Alright, similarly two inputs here, and similarly this is basically having the 6 inputs, that is for the select line and everything, because we'll be having the combinations like this. Like if we see the truth table, so let me just open Paint. So we are actually going to have this truth table like this, that is these will be the cases 0 0 1 1 and 0 1 0 1. Alright, so we will be having the cases like this, that in one case I0 should be at the output, another case I1 should be at the output, in the another case I2 should be at the output, and finally I3 should be at the output. So this is how the cases should look like. Alright, so we need to make sure that, that's why we have to add so many inputs and everything. Okay, first of all, let's just copy and paste these grounds. Here is the ground, here is the ground. These are the grounds we have pasted. Now let's save it and let's plot it. Alright, so here is the V plot. Okay, we will basically I will do one thing, I will not remove the sources from the inputs, that will be easier, I guess. Okay, not V plot, voltage print. Yeah, when we will be creating the symbol, I will not remove the sources, so it will become easier. And see, there is this print voltage, this print voltage. We won't be removing the print voltages as well because it is so much of labor work. Yeah, and finally the print voltage for the output. So this seems fine. Let's just save it and let's try to run the program. Before that, let's change the value of V bits, because we need to give different patterns, 1 0 1 0 1 1 1 1 0. I am just giving the random patterns. I will keep it as this one as it is, and let's say 0 0 1 0 1. Yeah. Now for S0 and S1. Basically S0 and S1 we want it to be 0 0. We want them to be 1 1. We want them in these combinations. All right. So let us make the pattern as, let's say, it will be 5 times 0, 5 times 1, again 5 times 0, 5 times 1. All right, and we have 0 1s, zeros and 1s. All right, so first of all it will be 5 times 0, so that we can get 0 0. Now it will be again 5 times 0, so we can get 1 0. Next it will be 5 times 1, so that we can get 0 1, and next it will be again 5 times 1, so that we can get 1 1. So this is how we give the patterns. And now let's set up the spice simulation. Here we are going to do the transient analysis, and let's take the stop time as 1000 nanoseconds, and let's take the maximum step as okay, let's take it as 10n. All right, so here we are going to include the library files. This is generate 250 nm, and we are going to add space. All right, so this is our 4:1 mux. So I'm just going to save it, and let's run the program, hoping our connections is fine. So we will see, for once there will be I0, then there will be I1, then there will be I2, and then there will be I3 at the output. Okay. So it seems fine till now. And we have the plot. You can see uh, what kind of plot it looks like. Yeah, so here you can see we have S0 and S1 like this. Okay, there are different kind of combinations and it is basically a bit difficult to analyze, but it's okay. You can see here this I1, this thing is getting first at the output, then another plot, this thing is getting at the output. Okay, it is basically becoming difficult to analyze. Let's zoom in. So let's zoom in now. Let's see. Okay, let's start from here. Yeah, so for here okay, anyways, so for here for S0 till this time, oh my god, let's open it in W8 once again. Yeah, we will just zoom it. Now we will start from the beginning. Okay, so we can see here that this thing from 0 nanosecond, both S0 and S1 are 0. So when these are 0 0, let's see till the time they are 0 0 which one they are mimicking. Okay, so when both of these are 0 0, I1 is getting at the output. Alright, you can see it is following the pattern of I1. When S0 is 0 and S1 is 1, let's see which pattern it is following. So when it is 1 and 0, okay, sorry, that was my mistake. When both of these are 0 0, the pattern it is following is this is also the same pattern till here, so that's why there was that mistake. It is following this as I0, and when it is from 0 to 1, it is following this I1. Okay, when it is 1 and 0, it is following I2, and when it is 1 and 1, it is following I3. So our 4:1 mux is working correctly. So I hope the schematic is clear. It is a bit messed up because there are a lot of inputs and output, but you can see this is how it is working according to our truth table. Alright, it was basically because this initial pattern was kind of same, so that's why we confused it with the I1, but this is the same thing till I0. Okay, that's why we got that same pattern. So this is how it is working properly according to how a mux should work, 4:1 mux should work. So this our schematic is working fine. Now what we will do, let's see, this time we are not going to remove the sources because it is kind of difficult to add the sources every time. So what we are going to do is let's just remove the sources from the select lines, because select lines we need to connect again and again. So here we will remove this print voltage and sources from the select line. I will remove it from here as well. Okay, we will remove this one, this major source, and we will let these sources remain. Okay, and we will let these print voltages remain as well, so that we don't have to add the print voltages again and again. We will remove this one. So now we are going to save the schematic, and finally we are going to create a symbol. Okay, so we have the input voltages already. Now when we copy that symbol, those print voltages and everything will be there. So our work will be reduced. So we'll click on generate symbols, and in this mux 4:1, we'll be going to click replace. Okay, so let's click replace, and here you can see we have I0, I1, I2, I3 and S0, S1. Alright, so these we are having here. And now let's do one thing. Since we already have those symbol, let's try to run this symbol first. So we have in this mux, we have our symbol 4:1. So let's go to cell, new, and we are going to name it mux. Let's name it 8:1 because we are going to create an 8:1 mux anyhow, but we will just run this 4:1. Okay, so we have this symbol, we are going to create an instance. So our symbol should have already the voltages for the input, and we just need to add the voltage, these input ports, that is I0, I1, I2 and I3. Alright, and here we have S0 and S1. So we don't have to attach any sources to I0, I1, I2, I3. We just need to attach the sources to S0, S1. So I will just name the output as Y, and there is our ground and voltage. So first of all, we will add ground and voltage. So here is our ground, and here is our VDD, and we will have our master VDC. Yeah, this one we are going to paste it here. Okay, so here we are going to copy it, paste it, again we are going to copy it, we are going to paste it. Yeah, so now again we will be having VBit, that is for the select lines. Okay, so here we have in our instance, so what I will do, I will just move this S0 a bit, or let's move S1. No, it's okay to move S0. Yeah, so here we have VBit. So I'm going to create an instance. Yeah, this is the instance for S0 and this is for S1. So we are going to copy the ground. This is our ground, and again this. Now the voltage print. Alright, so the plot, that is voltage print. So we are going to create an instance like this, another instance like this, and finally for the output like this. We are not going to add this thing. We are not going to add this thing, this voltage print in I0, I1, I2, I3 because they already contain that thing. Okay, so as we have seen in our schematic, they already have that thing. When we double click it, you can see all these things, sources, and these things are already present. So anyways, let's go back to our circuit. So here in this we are going to add only these things, and now let us try to run the program. Before that, let's change the patterns. We are going to change it the same way, that is 5 times 0, 5 times 1, 5 times 0, 5 times 1. Okay, this is for S0, and for S1 it should be 2, 3, 4, 5, 6, 7, 10 times 0, 10 times 1. Okay, that should be our pattern. So let's save it again, and finally I guess we are ready to run. So let's see if our 4:1 mux is working again the same way as it worked before. So we are going to add stop time as 1000 in, step as 10 in, and we are going to include the library files. So here is the library files, and I'm going to add space tt. So it is starting to run. Let's hope it compiles properly. So we can see we have all these traces. So that means our symbol is working fine. And we can see we got the same plot. So that means our symbol is working fine, it is working perfectly correct. Okay, so this is how we can generate the symbol for 4:1 mux. So now we are going to use this 4:1 mux to generate 8:1 mux, and the good news is we don't have to add the voltages and the sources for all the inputs. Okay, and this will continue till the time we get the 16:1 mux. Okay, so this is all for this video. See you guys in the next video.